Okay. Starting the stream as I move this around, create lots of bad noise. All right. This is stream 22. Let's update the today command. It does need to be updated. Edit com today. Right. The two things I want to do. I want to do adding proper error handling and integer types. Well, that's what the stream title is. So how can I elaborate on the stream title? How about we just say, like, making sure the ingestion, well, actually, it's all the libraries. Making sure the libraries should use first person or third person or second person or fourth person. Let's make it like the bot's talking, right? So it's going to say like Raimu is working on making sure. Hey, Jawandi, people flute. His libraries use good error types. Well, let's wrap this. Toggle word lab. Ryan was working on making sure his libraries use good error techniques. And also that 64-bit unsigned. Well, let's leave out the 64-bit part. Let's say that unsigned integers are properly supported, because they're not right now. Okay, now we're updating today command that no one uses. Close that. And see what the project command says. I haven't run this in a while. Resurrecting old tool for parsing binary files. It's still true. Okay. Okay, so finally got my libraries all building and running and passing their tests last night, even though I stayed way too late. The biggest thing that I worked on was I cleaned up the trait that we had defined for how data is ingested into the tool. So I had been trying to make every node in the output data structure have a copy or a variant of the bit stream that is like narrowly scoped to what are the bits that go with that node. But I abandoned that because I just didn't properly manage the lifetimes of the objects. So in our test, we're using this buffered bit stream. The add object has a lifetime constraint because we're holding a reference to someone else's buffer. And the way I had this before was you could ask a bit stream for a subset and would return a new boxed bit stream. And that was very hard to do with this borrow. So abandoning that and going to trait objects made it a bit easier to manage, at least for now. So the way it works is in the ingestion library, you'd call ingest, and you have to assemble this data component with arguments. So what's that? Well, there's the arguments. There's a bunch of data values. Could be empty. And then there's a data component. And so you have to initialize one of these. And you probably want to make sure error starts out at false, right? You have to say what the format of your data is. Keyed children will be filled in by the ingestion. So will the value. So basically what you have to provide are the format and the origin. Actually, you know what? That makes me think that we should actually, on this outer ingestion, maybe it would make sense to not put the data component in this one. Maybe we don't use that data type to pass it in because this is the outermost ingest, right? What if we passed in the arguments, the format, and the origin? Yeah, we made this origin type, which is a subset of a bitstream. So this is the, instead of having a new bitstream object, the bitstream subset has a handle to the bitstream and then sort of like boundaries around it, like where the component starts in the bitstream and how many bits total it can have. And the handle, this is where it gets a little bit difficult to explain because this is more like Rust Arcana. So we have a reference counted reference cell for a trait object. So some object whose type implements the bitstream trait. So far, so good. So an RC reference count means that we can share this ref cell. We can make, when we clone a bitstream handle, we're just incrementing the reference count and making a copy of the pointer. Now, what ref cell allows us to do is pass around and clone these copies, and you basically have non-exclusive access. So you can have lots of copies of it and still be able to mutate the bitstream. RefCell does this through a pattern called interior mutability. So at runtime, you ask to get access to the bitstream, and if some other thread currently has access to it, you actually get a crash. So it's fine for a single threaded application to do this because you're not going to have like, well, hold on, that's not exactly true. It is possible to crash even with single threaded. If you were to get access to the bitstream, and then while you're holding access to it, you call another function, and that function also takes the handle and tries to open the ref cell, you'll also get a crash. So you just have to make, we have to be careful that the scope in which we open up and get access to the bitstream is narrow. The alternative to using a ref cell would be to use references and to use immutable reference. But the problem with that is it's very difficult to share it. So another technique, if you really wanted to have like multiple threads and have them wait on each other and not crash, is we would use an asynchronous, an ARC, and then instead of a ref cell, it would be a mutex. And then in order to get access to the bitstream, you would lock the mutex first. So we can go to that point by changing this type at any time, because there shouldn't be any copies of this around. Actually, if there is, I need to fix that. That's just where, okay, so this type, I'm meant to have it reused. Oh, so I didn't do it there. So we need to reuse the type here. That would be bitstream handle. And we should just import it. Yeah, that way, like, we should only need to change it in one place. Okay, these ref cell news, I think we'll make that a function that we can call to do that. Maybe in the common test framework, so that only I need to change it in one spot. Because actually we're doing two things here. We're making a new buffered bitstream and stuffing it in a cell and having a reference counted pointer to it. We're also doing this as to use it as if the ref cell contained a trait object. So I learned yesterday that this cast is actually the way that you turn a cell containing a concrete type into a cell containing a trait object. And this is a form of type erasure. So once this is complete, bits is now a reference counted ref cell to a trait object, and it doesn't remember the concrete type that it came from, which is buffered bitstream, which is important for this ingest format because it is not generic, and it takes one of these, which contains one of these, which contains one of these, where this is a trait object handle. So we can't put a concrete type in there. The alternative would be to make all of these types all the way down from data components with arguments and ingest all the way down to data component and origin, or the bitstream subset. These will all have to be generic on where the type parameter is the concrete type of the bitstream. I was doing that before, but that's where the lifetime of buffered bitstream infected everything. So I wanted to avoid that by that level of indirection. Sorry about that. My voice is sore. Imagine that. A lot of streaming and a lot of typing. So if I made a helper, I think the way I would do it is, because all these tests are going to use static data arrays for the buffered bitstream, is that we'll just make, let's just take this, and in tests, we'll make a helper here. Because we have these other helpers like ingest and compile formats. Let's make someone called like make bitstream handle. Or how about bitstream handle from bytes? So we would pass in the bytes is some slice of bytes, right? And what we get back is a bitstream handle. And to do that, we do this. So it would be rc new refcell new buffered bitstream new bytes as refcell as rc refcell dyn bitstream. Oh, right. We have to declare a lifetime and use it. Yeah, this is, yeah, it's because of this lifetime, right? Let me get the full diagnostic from here just to make sure I understand it. Listening to this explanation of all the indirection, does your instinct suggest there's got to be a simpler way? Well, this actually is the simplest way because it's just difficult to express in Rust. Go back to data, or where was it? Bitstream, right? Too many files open. No ingestion. Yeah, where is this? It's in data. Okay, in data. This looks complicated, but in C, this would just be type def bitstream pointer bitstream handle. In C, it's just a pointer, and it's up to us in C to manage the lifetime of it, right? So because Rust is very strict about lifetimes and ownership rules, we have to wrap that bitstream into three things. We have to first say that, hey, this is really a interface or a base class, right? A pure virtual base class. That's what that's saying. So the actual type at runtime will be something that's derived from that. And the ref cell is saying that don't worry about sharing it. At runtime, we'll make sure that everything accessing it has exclusive access, either through a mutex or through like a panic if something already has checked it out, right? And the RC is doing the like counting, incrementing it whenever we make another copy of the handle and decrementing it when we release a handle, so that it knows when to actually free the memory. So this pattern's used a ton in C, right? Also in C and other languages like C++, the RC could be something like this, right? Use standard shared pointer to bitstream. It would be that equals that, right? So the standard shared pointer is the C++ equivalent of that. But still, even in C++, this concept of checking the thing out and having exclusive access isn't done for you at all by the language. It's still up to you to protect it. So you might have a wrapper around bitstream that has a mutex that you have to lock the mutex before you go into the inner, or you might have like next to the bitstream handle, you might have another thing like a standard mutex, and it would be your bitstream lock or something, right? And by convention, whenever you pass this handle around, you'd also have a lock that goes with it. So it's what I guess the point I'm making is this looks complicated, but so is the same way you do it in C++ and in C. It's just that the language is doing more for you in Rust versus having to like do more yourself in these other languages. Another alternative to making it simpler would be just not having a bitstream handle at all in the data component. So just remove this. But then later on in the evolution of this tool, I want to be able to like walk the data structure at any point and take a node out and put it somewhere else and have the knowledge of the bitstream it came from go with it. So it's actually, I'm kind of making it more complicated on purpose because I want this flexibility of a data component remembering where it came from. It's a helpful explainer. I'm glad it's helpful. So whenever I'm explaining, it's almost like I'm putting myself on trial and I'm the defendant's lawyer who is having to argue with many words why it was a good idea to do what was done or why I'm innocent, right? I think it's a good test to make sure, like, if I can explain through it and have feel good about my explanation, then I'm probably on the right track. If you ask a question and I start to answer it and I'm like, I feel shaky about my own justification, then maybe it's a good time to like reconsider my position, right? Could be that topic, but you're curious why Rust and something like Go. I tried Go, but let's see if this command still works. Why Rust? Right, so I do have a command for that. I prefer Rust because compiler is more strict. Once you get it to compile, it just works. You really need to use... Actually, I needed to use a debugger yesterday because it compiled and still didn't work. So it's yesterday was one of those rare instances where I still had issues, which is why today I wanted to focus on error handling, because lack of proper error handling hamstrung me when I was debugging. So the question like why not use blank is sort of a loaded question, right? Because it implies that you have some reason that you're not expressing about why it might be better. So got to be careful with that. In some streams, I know the streamer wouldn't like it. For example, Chris's stream, he doesn't like that kind of a question, but I'm okay addressing it. Really, it's just because this isn't my job. This is me doing hobby work, and in addition to the reasons about like why I prefer Rust there, that in the command, I also just kind of like find it fun and challenging, and it's an arbitrary choice. So if I had the same feelings about Go, I'd probably be doing Go instead of Rust. When it comes down to it, pick the right tool for the right job. And if you have lots of choices, pick the one that's the most fun, right? For me, Rust is fun. I do want to have this work here, but I want to understand the diagnostic. Cargo build, not pilled, build. Oh, because we need to do tests, right? It's in the tests that we have this. Okay, here we go. Lifetime may not live long enough. So it's this reference. Returning this value requires that must outlive static. Oh, exactly. Yeah. So I actually understand this error for once. Because we are making something that goes into a ref cell and is reference counted, it's going onto the heap, right? So anything on the heap, if you don't specifically say that you plan to deallocate it at a certain point. Like that's the, if you like, in other words, you create a specific lifetime for it, like it's trying to say here. If we declared a specific lifetime A, and then the compiler would, if we did that, the compiler would, as it's compiling, it would make sure we never call it in a way that we use the return value for longer than the same lifetime that we pass in, right? So it's saying like if you put an A here and put an A here, it'll work. In fact, I could do that. That's actually a great way to solve this. It would be to make it generic on some lifetime A that we put in this plus A. And then we have to do, since it's generic, we have to declare the lifetime. Okay, I thought that would work, but it didn't. Do we get a different diagnostic now? I thought that would actually fix it because that's what they... Oh, wait, no, it wants me to put that A on the type itself. We promised to return that type. That type has baked into it the fact that it has a static lifetime. In other words, it's on the heap and we have no guarantee of when we might delete it. So that means this has to be static. The only way to fix this, other than going in here and putting a lifetime on this and making it generic, which I don't want to do because that would lead me down the path I was on yesterday where I got really stuck. If I don't want to attach a lifetime to that, I have to use static there. And then we don't have to say anything there. There we go. Crap, even more to go look at in the rest docs. Never heard of a ref cell? Oh, ref cell is awesome. Here, let's do a little aside because I love talking about this stuff. Also, it helps me reinforce like what it means, and if I have a bad understanding of it, then we'll correct it, right? So it's a mutable memory location with dynamically checked borrow rules. So when you think about that, it's like if you've ever get into a situation where you have a mutable memory location and you have problems with the borrow checker, hint, hint, you could use refcell to sidestep borrow checking issues with mutable memory locations. So the way it works is the thing inside is mutable fundamentally. You're allowed to change it, but the borrow checking is no longer done at compile time. It's done at runtime. And the way it's done is every time you want to get access to the thing inside the cell, think of it like you put it in a jail cell. Now to get to it, you have to open the cell door, right? The way to open the cell door is this borrow or borrow mute, right? You either immutably or mutably borrow the wrapped, as in the jailed value. And the borrow lasts for as long as you hold the thing that it returns. So it's like, it represents a borrowed value, right? So you own that ref mute or that ref, and really it's just internally holds the reference that you're borrowing. And internally what it does is as long as this thing is alive, it remembers that you borrowed the value, so that if you try to borrow it again, it says, oh, wait a minute, you can't borrow it twice. Only one at a time, right? Another way to think about it, it's kind of like a mutex without actually doing the locking and the waiting. It's like a mutex that if you locked it twice, instead of waiting, it just panics. You think of it as a weak form of mutex. In fact, what you do, if you're going to go multi-threaded, is you replace refcell with mutex. You look at mutex, it's going to say, it's also protecting shared data. Whenever you see shared in Rust, you should think mutable, right? Or no, you should think that on the outside, it needs to be immutable. So it's got if it's mutable, it needs to be interior mutability. So interior mutability means you can share it, so it's immutable. The wrapper's immutable, but the thing inside, there's a way to get exclusive or mutable access. Actually, you can also think of when they use the word exclusion or like mutually exclusive or exclusive access. It's the same as mutability. If you can change it in Rust, you have exclusive access to it. They should have called it an X instead of a mute. Probably. But I think they wanted to stress the fact that if you have exclusive access, you're allowed to mutate it. You're allowed to change it. Versus if you share it, it has to be unchangeable. Would it make explaining these things so much easier? Yeah, probably. So yeah, use a mutex if it's multi-threaded. If it's single-threaded, you can go to refcell, which is a weaker form of mutex. So borrow is just like locking a mutex. So if we go to mutex, it's not called borrow anymore, it's called lock. Right? And lock gives you a lock result, which is very similar to that ref mute, right? Actually, I think it's not the result, it's this guard that you get back out of it. The guard object is like the ref. You use it as if it was a reference. Yeah, mutex guard. Yeah, it's an RAII implementation of a locked scope, so you can use it. The key is in the implementation of deref. So you can dereference the mutex guard as if it was a T, which is the thing inside. That's a fancy way of saying it stands in for a reference to T. You can dereference the mutex guard as if it was a T, which is the inner type. Cool stuff. Sometimes hard to explain and understand because of the arcane documentation surrounding it. Now there's a name I haven't seen like in forever. How have you been, Raimu? Hey there, Frosty. Been pretty good. I'm streaming in this time slot now. 7 a.m. to 9 a.m. ish. Sometimes longer, sometimes shorter, depending on my work schedule on Pacific time. And in the evenings, if I'm really motivated. If a question about the environment, every once in a while, see you access very quickly a page with links. Okay, so the OS I'm using is Xubuntu, and Xubuntu has this concept of workspaces. So I'm clicking down here. So I got 4 workspaces, right? So I set up my editor on one workspace and my web browser on the second workspace. And then if I hit Control Alt left arrow or right arrow, I'm toggling between the workspaces. So that's all that really is. And I think in Mac OS and Windows, you also have that concept of like different workspaces. And I just use it as a convenient way to quickly get to the browser and back. Because my area, I have self-constraint. I want the text to be really big. And so even though I got a lot bigger monitor, if I used all the monitor space, the text would be too small for you to read. But then where would a ref cell be useful in single-threaded context? It's when you have when you're copying the reference to that the reference to that ref cell around in your code, and when you're passing it around from one function to several other functions, that you need to share it, like you're making copies, right? And you can't do that if it's mutable. So the ref cell allows you to share. Ref cell allows you to share something and still get mutable access, exclusive access. It's the same as a mutex, right? You can pass around many copies of something protected by a mutex, as long as whoever gets a copy has to lock the mutex first before they access the thing. So ref cell is the same thing, just without the waiting on other threads. If you lock or borrow a ref cell and the cell was already open, someone has already borrowed it, you get a crash. Rust has stricter reference rules in CS. Yeah, so the ref cell is a way you sidestep the reference rules. Ref cell is necessary to establish the restrictedness. Yeah, exactly. In C, having 2 mutable pointers to a thing is valid. In Rust, 2 mutable references to undefined behavior. Yeah, so if Rust allowed you to have 2 things having access to the same thing and being able to change it, it would undermine all of its types, all of its runtime safety features. So they have to be very strict about that. The ref cell is you manually opting out of that. Same thing with mutex. You can't just actually. There's a third way, which would be to write unsafe code with pointers, and then you're just telling Rust, just give up and don't even do the borrow checking at all here. But we try to avoid that. So refcell is like bending the rules a little bit. We're saying like, don't check it at compile time, check it at runtime instead. Yeah, well, thank you, chat. Your explanations oftentimes are better than my own. I appreciate that. Yeah, so because I might change this to a mutex later, I want to minimize the number of times we mention it. So that's why I made this helper. So we should be able to say like this and that, and it's actually easier to read now. Bitstream handle from bytes. So we need to do that a few more times, right? Bitstream handle from bytes. It's a lot less punctuation, which is nice. Oh, this goes away too, right? So there's an empty 0 bytes. Okay. All this gets replaced with that word, and then all of this is deleted. And just like usual, I haven't even yet really gotten to the whole point of today's stream. You know, sometimes it happens. I'm like talking about a thing and I realize, you know, that might not stay at a ref cell and an RC. I might turn that into an arc and a mutex at some point. I'd like to have it in as few places as possible so that when I change it, I only need to change it in a few places and not like everywhere like I'm doing now. If I was better at like design, I would realize that earlier and I wouldn't have to do all of this going back and changing everything. And probably if I stopped for a little bit and thought about it, I could have done this with a search replace, right? But sometimes I just kind of take the lazy approach, the non-thinking approach. I'm like, oh, just do it. Sometimes you just need some like grunt work so that you can kind of like let your mind relax a little bit. Some busy work, right? Okay, so now the fact that we're using RC and refcell is only in there and there. Only in these two places, not counting the uses, because those are easier to manage. So here's where we create them, and here's where we define the type. Everywhere else, it's through these abstractions. As a programmer, you often also explicitly rely on the fact that you know that a mute, one of these, is the only pointer to that thing that lives in the entire program. For example, doing foreign function interface. That would be like if you call a C function from a Rust function. For example, if you write a mutex T like type, you can implement a method that accesses the inner type without locking the mutex if you had a mute self. Yeah, there's a shortcut. That's a good thing to point out because I forget that a lot. If you have a mutex or a ref cell, you can, and you know you have an exclusive access to the mutex, you can sidestep the lock completely. That is get mute. It says, since the call borrows the mutex mutably, no actual locking needs to be in place because the mutable borrow statically guarantees no locks exist. I think the reason why you get a panic is you could call get mute twice, right? No, wait, this one the borrow checker figured that out. How could this ever error actually? Oh, this is if it's poisoned, right? You can poison a mutex by panicking while holding the mutex. This panic while holding it poisons the mutex. So then if you try to lock or get mute a poisoned mutex, you get an error. Yesterday was a pretty good day. I actually did not feel you were a stupid noob and got to teach Togglebit. Oh, nice. What'd you teach Togglebit? I haven't seen Togglebit streaming. He must be streaming while I'm asleep. or working. That's possible too. If the mutex is poison, right, Raymarch? So as long as you don't have a poison mutex, which involves panicking, then you always get access to it, and you don't actually need, no actual locking will take place. So ref cell has the same thing. It's called it's not borrow mute, it's like get mute. There we go. And it says the same thing, which should be another hint that ref cell and mutex are brothers and sisters, right? So statically guarantee that no one else is borrowing it, so the dynamic checks are unnecessary, so it shortcuts the process. Okay, so let's actually get to the point of the stream today, which was to do better error handling. So I think the way I want to do this is drive it through tests. Maybe we do it at the parser level first. I want to like manufacture a parser error and make sure that the error message we get out is useful. So let's close everything. And then we'll go into, oh, I should have shown this. For anyone who hasn't been watching my stream, the overall project is called the DataDisintegrator because I'm terrible with names. It pulls apart all the bytes of a binary file or a stream, and it assigns meaning to every piece of it based on a description of the data format written in a domain-specific language. Here's an example of what that looks like. So a GIF file starts with a header, ends with a trailer, has some data blocks in it. There's a logical screen which has a descriptor and a color table, and the descriptor says how big the GIF is, right? So if I were to do this with this file, so the GIF file you can actually see it here in the decoded text. There's a GIF89A, and then there's some stuff that's not a string, right? If in our description, a header has a string called signature that's 24 bits long, another string version 24 bits long, then it's going to take the first 24 bits, interpret it as a string like this decoded text does, say, okay, that's the GIF signature. Next 3 bytes version, right? And then the next thing was the logical screen descriptor, which starts there. And if it's a little endian, then 16 bits of it is 300. So that's what we see there. So it's a decoder, and it's a generic decoder because this you get to write, and it's compiled it's just in time compiled by the tool. So that means there are 3 parts of it. The first 2 parts form a compiler because we're turning an input program into an abstract syntax tree. And we're using that in the third part to break down the data into elements and determine their meanings. Basically, we do an in-order traversal of the abstract syntax tree along with the input data bytes, and we output a data composite. And the composite has nodes, and each node represents a piece of the file. So in the output here, this is a node, that's a node, this is another node, which is a higher order node because it contains the other 2 nodes, right? Every line here is outputting a diagnostic about some node in the data tree, right? And it remembers where in the original file it started and how big it is in bytes. So that's the whole point of this. Compilers typically have 2 parts. You don't go directly from your input program to an AST in a lot of compilers. The traditional ones will first turn it into a stream of tokens, and then that's called the lexer, and then the second part, called the parser, is going to interpret that stream of tokens using grammar rules. So I'm going to work on this parser here because I want to intentionally violate a grammar rule and make sure I get a syntax error, and I want to make sure that the syntax error is readable and useful and not devoid of helpful information. Oh, you're teaching toggle bit electronics? Oh, as a side note, you can try borrow a ref cell, so if someone else happens to have it, you don't have to panic. I always think of that as like you're just too nervous to borrow it. You should have confidence that borrow will always succeed, because if it doesn't, you'll be debugging. If you don't want to have panics, true. Like if you're not confident in your design, then yeah, you might want to test for a panic, and then maybe I don't know what you'd do if it fails. Would you just print an error log message and then hope that the program continues to run in a defined way? Tugabit was working on a basic D electronic, creating a do-it-yourself keyboard. You mean like this? You mean like this? Creating one of his? Shameless self-promotion here. Keyboard. That was last year's project. Taught him to use a basic multimeter, multimeter, however you want to say it, how to check an LED light emitting diode, and how to check voltages and shorts. Those are good skills to have. I've got one of those multimeters. It beeps if there's a short, and that's what you want. You want to give Rust another try? You read through the Rust book and tried some stuff, but you got caught up in a lot of nuances in the language. Yeah, that happens. There are a lot of nuances in the language, and I tend to think some parts of the Rust book are not written very well. Because if they were, then all of us would think, oh, this is totally understandable, and now I understand Rust. And there aren't nuances. Have some sophisticated error tracking in your library. It's a shader generator. If it breaks anyway, we want people to be able to catch the error. Yeah. So minimally, if we have a syntax error in something like this, like if I were to forget this semicolon, I would want it to say, you forgot a semicolon. Or at least it should say there is a syntax error on line 4, right? So let's see what we get from my existing C++ tool. We get a syntax error, and it actually tells us the token that hit it. So line 5, columns 5 through 9. 5. Yeah, it says when it sees the while, there's a syntax error nearby. So that's good enough for me, because I'd be like, okay, there's something near this while, there's a problem. So let's look down. No, that looks good. Let's go up. Oh, missing semicolon. So even better would be we could add a grammar rule that intentionally looks for a while token that didn't have a semicolon right beforehand. And we would say, oh, missing semicolon, right? Question is that's the C++ parser. Does the Rust parser look any better? So I'm going to do cargo run bin lex and then stage and then gif.fmt. Oh, that's the lexer. I want to run the parser. Parse. Yeah, see, this is inadequate. Parser error. Oh, it's an error. Okay, where we want to at least minimally know where the error was, right? So let's put that into a test. Let's close everything. Parser should have a test for this. Tests. I suppose it would be, in this case, it's like a specific kind of error in a statement list, right? Would that be format? Because the format has a statement list. Yeah, okay. This maybe is a good place. Because like we have a format with one statement, and then we should have another test for the format with 2 statements. I don't. I have a one statement with argument. I think the other problem is, oh no, we're assigning locations to the tokens on purpose so that we should be able to get a location out of a syntax error. Yeah, okay. Then, yep, then let's make a test case. Right here. So this is missing semicolon between statements. Or actually it's right now it's a semicolon, missing semicolon at statement end, right? So it's if I intentionally lost that semicolon, that's an error, right? Because there needs to be a semicolon in my language there. So we would get an error. Question becomes, what kind of error? Oh, I didn't mean to click that. Just let it fail. Okay. Right, so we expect a certain kind of parser error. Actually, it could be that this contains the location. We're just not formatting it correctly. So we might actually pass this test, right? A parse error. Okay, there are a couple kinds of parse errors: unrecognized token, unrecognized. So this is from Lollipop. I actually don't want to see it here in Lollipop. Yeah, this parse shouldn't be exposing that type. Did I make a mistake? Oh, no, we're using it internally. Oh, I don't want to do that. I want to use the external interface. Why am I testing the grammar internally? I think it's because this test is targeting the grammar specifically. Let's make another test function that actually tests the external interface. Yeah, where would I want to put this? Yeah, we don't have any tests of it anyway. I just don't know what to call it, like API. Sure, we'll call it API. So in tests, there will be an API statement. API tests. I don't know, where am I copying from? Something simple. Yeah, like this. Okay, and then API. I don't want to use that parser. I actually just want to use the API level, which is one of these. Parser new. And we should get a parser error, which, okay, so yeah, we're missing the location information from that. That's the problem. That's a problem. So we want a oh, where are we? Right here. Test missing. Well, test API, and we're going to use the test case. Let's get rid of this. Actually, I guess we do want an empty format, and then we want to like have like we would actually want to kind of steal from this. I want one of these, right? This is with, yeah, I want one of these. I want it empty. One minimal format. I need to make sure that the result is correct. So the result is going to be, I guess we're going to iterate it, right? We're going to get a hash map out of it if it's successful. Or should I just be copying that? I think I should. That should go here. And the input is what? Input's that. So a bunch of those. Actually, let's generate the locations in the test like we're doing here. And so yeah, so it's just vec token. Okay, cool. So the result is just a little bit different. So here it's going to be parser from the crate, hash map from standard collections, format from AST, parser error from the crate. Actually, the crate should have it. Where's parser error? Oh, that should be a pub use, shouldn't it? Pub use error. Because we want to re-export it. Yeah, okay. These other ones are all private imports. Although, well, token we should be getting elsewhere, right? Okay. Then that should import from the crate. Cool. So for this to work, this input doesn't match, right? Vector of results. Why is there a result in there? There should not be. Parser takes location token location. Location token location. This should not be an OK. It should just be that. I don't remember why there had to be an OK there. I think that's right. That's how the lollipop generator parser works. But this shouldn't need that, right? Are these not comparable for some reason? Why not? Okay, we need a partial equal on parser error. Okay, well, that's the first thing we need to fix. Parser error, we need to be able to equate them. Okay, that solved that. But yeah, we have to change this, right? So if the format, if it's okay, then we're going to have, and I think I'm just going to use the hash map macro for this, which we're going to get from maplet. And we expect here as a string, foo is a string, right? Constructs a format which has a certain name, and we're putting the name goes in there again. Looks like it's up to me to format this. Oh, because a T got in there. How'd that happen? Okay, and the arguments they're both vectors, right? So these are both vectors. And it has no statements and no arguments, right? Okay, so this should be an empty hash map. So I should be able to, okay, let's remove all the things we didn't need from here. And let's run all of the tests at the API level. So if I close others, too many things open, right? Just open the tests and open API. Okay, and then I should be able to just shouldn't it let me run these? Wait. How come the tests aren't in a config test? Oh, is there okay, hold on. Is there a build issue that I'm not seeing? usually Rust Analyzer identifies that we can run tests in here, but it's not doing it. It's doing it at the low level, but it's not doing it at the higher level here. How is that working in the ingestion library and not here? Injection source. Yeah, I have a run test. How come I don't have one over in the other library? Right here. How come I don't have... How come you no give me tests, Rust Analyzer? Run tests. It's not here. Do I need to have that on no? Not on a line on its own? Oh well, so we can't... We're crippled. I don't know why. So I guess we'll just run them manually one at a time. Run empty test. Pass. Run minimal format. Pass. Run all of them. They both pass. Okay. So now finally the error case. So it would be it would be almost like this, only without. Actually, let's have one, because I don't have one with a statement in it, right? I was gonna steal that from the format. This one has a similar test, right? Here it has a format and a semicolon in it. And that's in here, right? So this is format with statement. Valid statement. Just statement. We don't have to say it's valid. So here, I can again steal it from this, right? I put one of these. Import statement. Whoops. I don't want to qualify it. Right, sometimes that little helper thing doesn't show up until I do that. It does qualify, but I don't want to qualify. I want to do the use. Okay, now we got it. Okay, so format with statement. Hey there, Sarian. How are you doing? Passing our tests. Now to make one that fails. So this is a format with statement missing semicolon. Let's just say statement missing semicolon. So we just remove the semicolon. We should get an error. And the error should be of type parser error. And all we can say about it is that, right? So run that. Make sure we do get a parser error. Okay, now test-driven development. We don't want it to just say parser error. We want it to say parser error of type of syntax error, right? Syntax. And let's just minimally just have a location. Location comes from AST. Why is it AST panic location? No, it's token location, right? And that's a struct with a line number and a column number. So the line number should be 0 because in our test we're generating, oh, actually we're not doing it. I need to fix that. I need to actually use a different location for every token. So counting the token 0, 1, 2, 3, 4. So it should be at 5, right? That it identifies a problem. Okay, and then let me fix that. I'm just gonna do the same thing we did in format, where we have like this little enumerate thing. Into iter map, so it's enumerate and then map token into something bigger. There. Except we don't want the okay there, right? This thing is smaller. less code. Okay, cool. So we need to define parser errors in enum with the syntax variant. Enum, and there will be a location attached to it from token. Okay, and then so display, let's have a match self. It's a part if it's a syntax error with a location, we're going to write syntax error. Let's put the location in front. Okay, so then back, run them all. Okay, so in here, I must have had an yeah, okay. Okay, yeah, so we can't map, when we map, the error of parse is a different kind of error, right? We get, I forget what it's called, like a grammar error or something. Let's see what this thing says. It expected, actually, I can just do E here, right? And see what is the type of E. Let's make this to do. I want to at least see what the type is. That's not helping me. How come the inlay hints aren't working? What's the trick to do that? Let x equal E. Let x, which is a unit, and then I should get a compiler error saying that x needs to be of a certain type. There we go. We get grammar, lollipop, so parser error location token, and then empty. Okay. We get that, right? Well, wait a minute. I don't actually need to know the type. I just need to get the location out of it, right? How do I get the location out of it? Would it be .0 or something? Yes, it is. Oh no, it's not. Uh, what does a parser error have in it? How are we gonna find that? Is that in maybe the lollipop documentation? Thing is, it's generated code, right? So I don't know. I don't know where to look for that. Do I look in their guide here? Error recovery. Here we go. Okay. Hey, the error token will be a parse error value. Ooh, why did it just start blinding me? Okay, so it's an enum. That's why I can't access it. So we actually have several types. So that means that I should be able to do like a map or match and have this automatically generate some code for me, right? Nope, it's not smart enough to do it. But looking at this, it should be one of these, right? Parse error. So now it's resolving. Location, token expected. Token and error. Okay, and all of these we need to do something, right? Let's do the same thing for now. So this is location. Do we not get a location for unrecognized token? Or is the expected have a location in it? Oh no, the unrecognized token is an option. Wait, why would there ever be none? If this is none and end of file was observed. Okay. So let's make this to do. We'll handle this later. Extra token. That's also. Oh no, that has a location in it. So token.1. User error. We don't know what to do with yet. Parser error. Use lollipop util parser error. Yes. Unrecognized EOF. Was that not on this list? Okay, well, I guess we have a non field match arm. There we go. We have unrecognized EOF. I guess. Yeah, okay, fine. What's wrong with this? Oh, is the token, okay, there's a location, token location. Why are there two locations? Oh, because it's the beginning and ending line number, column number. So I guess, actually, then the syntax should probably have two locations in it, right? So invalid token only has one location? Invalid token generated when it encounters a token it did not expect. Yeah, but I guess that would be the beginning. Is it to do built in? Yeah, it is. It panics if you hit it. It's a special kind of panic that says it's not implemented yet. It is pretty cool. Hey there, Metal Storm. Well, thank you, Teroxy. Might show up every now and then. That's great. Yeah, I got to do my daily stuff in about 20 minutes. What's my opinion on GitHub Copilot? I've never used it. Sarah Yen, you're not doing too bad. Me, I am a little bit tired because I stayed up too late getting this all to compile. I'm sure you would have been able to get yourself out of the bind I was in a lot quicker. I went down the path of doing lifetimes badly. Would I expect UF be better? Well, it generates this type for me, and this must be old because they don't list this. But yeah, I'm just gonna fill in I'm just gonna fill this in for now. What is it? That, but then put the location in here. Maybe I shouldn't do it this way. Maybe these should be all. Yeah, that's what it should be. These should all be to-dos. We should first have the first level of to-dos, right? To do. And then we'll fill them in. We'll fill them in test-driven development is what we'll do. make sure this builds, and then have the test drive where we fill things in, right? Yes. So run the API tests. So we'll get a non-implemented error. Build. Panicked at not so this is what you get for that to do macro if you hit it, not yet implemented, and then it tells you where, and you can click it and say, okay, we hit unrecognized token, right? Okay, the token is actually tuple with locations in it. So yeah, I think I actually want two locations, right? Beginning, ending. This is a Lexer location, a token location, but I want another I don't want location. I think what I want is a span. And a span will be two locations right now, right? I suppose we make another module for this. Span. Lib level will do use span, or pub use span. Oh, itchy ear. Mod span. My ear itches for some reason. And I'm whacking the microphone, putting loud noise in your ears. Yeah. What happened to the multiplayer RPG you're working on? Pomp Rocks job rules command explains that. So I have a day job now that doesn't let me do game dev. They just have a clause in their when I got hired, and they told me about it while I was being interviewed, and I weighed the benefits versus the good versus the bad. The bad was that I had to stop working on that game. The good was that I got money. I got monies. Sometimes you just gotta get paid, right? And put the game on hold for a while. Okay, span, pub, struct, span, pub, begin or start and end, I guess. Import location from token. Okay, and then error, import crate span. Where's that grammar error used anyway? Final references. Wait. Oh crap. I'm gonna have to change all these tests? Well, that's unfortunate. Looks like, yeah, I had two different errors. Well, let's bite the bullet. Yep, now we're gonna have all our tests break. What's wrong with this? Span doesn't implement debug. Oh, yeah, let's fix that. Derive, debug. And we also need to derive partial equal, right? For the test to make sure that the errors are what we expect. Okay, so this is a span. And I do want to implement display for span, so let's do that. Okay, so this is going to be write f Is it like typically like that? self start, self end, where each of these is like line number, column number, line number, column, colon number. We have just a dash. Okay, we didn't use that because it's now pushed into span. All right, yeah, we have to fix all of these, right? Why do I have this here? Was that so I could inherit it? I think so. Parser error, right? And all the tests are broken. Yeah, so this should be, there's a span here, right? Start. And then the end will be one more over, right? End on column 6. Use span. So I could do it this way, or I could actually turn this into a string. This is probably better, right? If the display trait is wrong, we'll see that later and we'll just fix it. Okay, getting there. I have to fix all the other tests too. It'll have similar things, so why don't we just prepare to copy paste this. Wait, this type is derived. Wait a minute. Is that that's the like user error, right? Oh, shoot. I want to keep that type. Yeah, these are internal parser tests, so we're not testing the external type at all. So, but I don't want to re-export that from error. Where do I want to put that? Maybe at the lib level? So internally would declare a struct. I guess it would just be an empty type, right? Type. Right now it's an empty type. Grammar error. That's why I called it grammar error. It's an error that is generated inside the grammar. Okay, that should fix a lot of things. It didn't fix things, so why not? Because the tests don't do a import. Yeah. So this should just be grammar error. Actually, I should have both of them. Use create grammar error. Uh, why does this say it's not used? Probably because the API test didn't. The API test probably imported it directly. Yes. So we shouldn't need to do that. In fact, shouldn't I like try to minimize these uses at the top? I can do that by this should be the only use. These should be common. So why don't I just take all of these out and put it at the tests level? Because this was supposed to like have common uses in it. Like that. Oh, we can't put the test case use there. Okay, right? this has to be like, because it's a macro or something, there's some weird rule about that. We had to put that there. Okay, so then I should be able to remove every use except for those 3 from all of these. Why? AST binary. Okay, binary operator needs to be used at the top level. This thing. It's just cut. And then up here, paste. All right. All right, all right, all right. We're moving on. 1, 2, 3. 4, 5, 6, 7, 8. If you're wondering why there are so many exprs, this is how we do operator precedence. We break the expression grammar up into 12 different tiers, from most highest precedence to lowest precedence. Lowest precedence is the binary OR operator. That and that, right? This I'm not sure if we import in the helper up here. Looks like we don't. So paste. Okay. Format. Let's put that in tests. So just everything will be able to use map. Actually, is that going to work? Formats. Or am I going to have problems? No, that worked. Okay. So I shouldn't need that. Collections? Yeah. Let's do that there. Yep, resurrecting an old tool. DataDisintegrator. It pulls apart the bytes of binary file stream, assigns meaning to every piece of it based off of the description. So here's an example format. GIF file has a header and a trailer, and it has data blocks in it. So when we run it, okay, I have a syntax error in there on purpose. Let's fix that. We should be able to, if we have like an example GIF file, pull off that this is the header, because the header has a string signature 24 bits long and a string version number 24 bits long. It generates in the end a tree of data elements, and each data element has a value. It has it remembers where it was in the input file and how many bytes it was. So it's comprised of 3 parts. The first 2 parts you can think of as a compiler. So we're taking that input program, which looks like that, and compiling it by turning it into a token stream and then applying some grammar rules to make an abstract syntax tree. And then what we do is we take the abstract syntax tree form of this and do an in-order traversal along with these input bytes. And that generates this output data structure. I was around here somewhere, right? Yeah, I'm trying to remove all the redundant uses, so that shouldn't be there. Let's make sure that all of these are in tests. Okay. Yeah, ideally all of the tests should only include super and then the specific thing they're testing and test case. So like I shouldn't need to say that there. Okay, cool. Moving on. Yeah, we shouldn't need to pull that in or that. Just testing a grammar rule only, right? Delete, delete. And delete. And delete, delete. Delete. Deleted. So I'm able to delete these and it still builds because this superstar is I'm kind of cheating and I'm just pulling all the common includes one level up. And I figure it's okay to do that. Normally I wouldn't do this, but it's okay to do it for tests. Tests kind of have their own set of like things you're allowed that I allow myself to do. Okay, cool. So all these are nice and clean now. They should only include the thing that they're testing, the test case because we have to, and then our common imports for all tests. Okay, I think it's looking good. I don't think I need to actually look at all of them. Yeah, so this one I shouldn't need any of these. Or that, or that, or that. And let's make sure that that is pulled in by the tests. All right. Cool. Okay. So I run this then? Make sure we got it to pass? No, we have a syntax error. We have an error somewhere. Unresolved import. Oh, that's in the generated grammar. Yeah, so the input to that is grammar.lollerpop. So there I have to make sure that the use is correct at the top. And yeah, it's just create grammar error. Oh, I'm running out of time. There's this thing called work that I have to go do. But okay, it's building, so I should be able to like see nice test passing now, right? Tests all pass. First try. Some warnings. Should get those warnings taken care of. Nope, we have a failure. And the failure is not yet implemented. Somewheres. Okay, it's unrecognized token that we need to map to our syntax error, right? So map that to parser error. Syntax, and then I want to put a span in there, so that's span. Start and end. So the start is token.0 and the end is token.2, right? So then that should fix the test. Why is it taking so long to build sometimes? There, we fixed it. First try. Oh yeah, where are these warnings? Oh, right. I think I'm gonna follow the pattern that we don't fill this in until we actually need it. Okay, but do we want to include the expected here? I think since we have it, we can expose that, right? So we can say we don't just expect a syntax error. Let's say like token expected. And then we'll have, wait, go back. No, it's unrecognized token. How come my forward key's not working? My back key's working, but my forward key's not. Now it is. Weird. Yeah, why don't I just map it one-to-one then? Unrecognized token. So, the token would, well, like actual unexpected. The forward and the back not working for me right now. Token and expected, yeah. So token has the span in it, so we'll make it say span there. And then I will make that a structure. So this indents and this outdents. Okay. So the actual token would be this token R brace, right? And the actual token, the expected will be a semi. Okay, so I got to actually fix parser error then. Come on, jump to it. Help me out here. Okay, here we go. That actual token expected token span token comes from token. All right, gotta end soon. Yeah, so hold on. If I comment that out briefly and then I can do fill match arms and I get that for free, and then I can uncomment that, and actually I can just do this. So we have the span, and let's see, expected bit found, expected found actual. As long as those support the display. Okay, they don't support the display trait, so let's do the debug trait for them. That should be good enough, right? Okay, we can do this. Wait, what? Oh, yeah. We're turning one error into the other. So that's span is that actual is token.1 expected is expected. That's a brace. That's like that. No, second brace. Get rid of that. Auto formatted, we're good. What's wrong with this one? Found a vector of strings. What? Expected is a vector of strings? Oh. The parser doesn't translate them back to tokens, and there's also the expected could be an array. So let's just remove that part right now. Yeah, we're not going to use expected, which means that we should use a dot dot there, and maybe I should leave myself a note. So like to do, because I'm running out of time right now. Well, the parser generator. The parser generator gives us the whole list of tokens that would be accepted, but it refers to them using the strings from the grammar rather than using the token type. So I would have to have like a runtime way to the to-do should be a short thing, and we can have a break and then explain it, right? So consider using expected. The parser generator gives us a whole list of tokens that would be accepted, but it refers to them using the strings from the grammar rather than using the token type. So yeah, this we were going to remove expected because we're not handling that yet. So this should just be unexpected or actual unexpected. Go back. Where's the error? Come, I don't see the error. I see a bunch of oh, here it is. It's this expected, right? It's gonna say unrecognized right brace, and that'll just be my clue that there's no that the semicolon's missing. What's wrong with this? Expected a comma somewhere? I don't see where. Oh, right here. Will expected always be a single token? No, it can be a variety of tokens. I can show you an example in the parse, like if I go to statement, I think. Or no, I did this in expression 0 test. I remember this. So at the bottom here, there's these expression first tokens. So if you're trying to parse an expression and it's empty, it'll be like, well, I expect one of the first tokens in expression. So the first token of an expression could be a literal decimal, a flip, an identifier, an integer, a left brace, a left bracket, left parentheses, less than, a minus, a nil, a not, or a literal string. Those are all the ways that a valid expression can start in my language. So there's 12 of them right now. So you would actually get the full list out of the grammar saying that we need an expression here. Expression starts with one of these things, right? Sort of a weird thing that for the parser generators to do, I think, but that's just what it does. Why am I still getting warnings here? Oh, because I'm not using these. ... for now. I want to see 0 warnings, 0 errors, and I gotta prepare for a meeting soon. That's the question when you define expected as a token. Yeah, it was wrong. It needed to be like a vector of tokens, but I have no way to map between the strings to the tokens in the Rust code. I have it in the grammar, but it's the other direction. No, it is correct direction. Yeah, I have this at the bottom. There's this extern. So this isn't valid Rust. This is in that lollipop syntax, right? So there's this. There is a mapping from string to token, but the errors don't use it for some reason. And I don't think this actually... It would be convenient if this generated code that let me call it and turn the strings back into tokens, and then I could do a map from the list of strings to a list of tokens, and then I could actually print them. But then again, does it really make sense for the compiler's error message to say, here are all the things that could go here? That'd be kind of weird, I think. API, right? Missing semicolon test. Oh, passing now. All our tests pass. Right? Cargo run tests, all the tests in lib. Oh, actually, this isn't build. I want to do cargo test. No, not the ingestion library. We're in the parser library right now. 116 tests. So somewhere in there will be the API tests. Here we go. Okay, cool. I'm running out of time though. So I did very little of what I expected to do today. I only did one test of... Actually, well, I can make that the thing I ran before, right, where I intentionally put an error in there. We should be able to see that now if I did it right. Take out that semicolon and then do cargo run. Yeah, run parse. There we go. Error, line 4, columns 4 to 9. It's this local right here. It's like while unexpected. Oh, I guess it's right. It's counting from. So I should add 1 really when I print it, right? Because lines start at line 1 for us humans. Even though for a computer this is actually line 0, for us it's line 1. So it's really line 5, columns 5 to 10, which is this symbol here. So it says the while is unexpected, and that's because there's it should be a semicolon. And that's the actual output if it works. You get the whole abstract syntax tree out of that. Okay, I gotta run though. We'll add more errors because I need to fill in all of the where is it? Why are we refreshing Chromium now? Error. Where was it that we did this? How come my mind is blanking? Yeah, it's in... Right, it's in our implementation of the... it's in when we map our errors internally to the API, right? I wanna write tests that hit all of these to-dos, and then we fix them. We might not even have any of these, actually. That might be hard to do. So we'd have to actually, I think this is where when you make a grammar rule that emits an error, that's a user type, and that's where we put that grammar error, right? Yeah, so that's the objective of the next stream, is to get rid of all these to-dos. So I gotta end it there. Gotta go do work. Let's go and watch Tim, I guess. Bye-bye, everybody. We're gonna pass you over to Tim Baudet. Probably won't stream until tomorrow at 7 a.m. Pacific. So until then, take care. Bye.